Okay, so today what we're going to do is we're going to look at how well we understand how to solve an equation. By looking at what are called literal equations. These are also known as changing the subject. You're going to change the subject. In other words, you're going to solve it for one particular letter. And the reason why I say that this tests how well you understand algebra is that you will literally follow the steps, hence the name, to solving the equation for a given letter. Most of these will have no numbers in them at all. Maybe a few will have numbers in them. So your job is just to rearrange the equation so that it's solved for the letter that they ask you to solve it for. But remember, your whole goal for solving any equation is to get the x or whatever letter by itself. And you do that by doing the opposite operation. And I've given you a series of steps for first cleaning up the equation. What do we always get rid of first? Look for first. Brackets first, yeah. And then fractions. Then combine any like terms that are where? On the same side. Excellent. And then we get all our variable terms on one side and our number terms on the other. And that's where this goes slightly different. Because our variable term is the one that is the letter we're trying to get by itself. So everything else will behave like a constant or a number term. It'll move to the other side. Okay? And then you just finish it off by dividing by the coefficient of the variable term if there is one. Because remember, you're not done unless that variable, whatever that variable is completely by itself. Okay? So what we're going to be doing is we're still just solving equations. So those steps don't change, but for a given letter. Now they can give you a symbol because there was one I saw where you had to solve for pi. And that means get the symbol for pi completely by itself. Okay? So all that means is get that letter completely by itself. Literal equations. Or changing the subject. You'll see it both ways. You hear a lot in New Zealand it says changing the subject. Get that letter completely by itself, and you do that by simply using the opposite operation. So if two things are connected with addition, how are you going to take them apart? Subtract. If they're subtracted, you will add. If they're multiplied, you will divide. Okay? And again, that's after you clean up the equation with the brackets. So we can write those steps real quickly just so you remember. First it's brackets. Then it's clear the fractions or decimals. Wait a minute, how do you put decimals? I don't think. Then it's variable terms combine like terms on each side that are on the same side. Combine like terms on the same side. We've written this a lot, so if you don't even have to write it if you don't want to. For variables on one side, 5 constants on the other. And remember, this time, the things that are usually numbers are going to be just a bunch of letters. Mm-hmm.
What is the first word for letter 4? Number 4?
Okay, for number 4, it's variable, VAR. Okay, I just got lazy. And then finally, divide by the coefficient. Now, there is one weird thing that can happen to you. You can have your variable occur in 2 terms, in which case you'll have to factor it out to make it turn into one thing. It'll be a GCF, and you'll divide it out, and then it's one thing. And you'll see, I'll show you an example of that. But be careful, they love that one. So, okay? See, combine like terms. Sorry, really being lazy today. Combine like terms. So this is the exact same rules we wrote down for the equation solving, so you don't need to rewrite them if you don't want to. Okay? So let's just look at a really simple, really common one. We're going to look at the formula for a perimeter. Perimeter is, for a rectangle, is 2L plus 2W. You've seen that formula before, right? Okay? You have 2 lengths, 2 widths. You need to add them all up. Okay? So this is a formula. We couldn't really solve this for any particular number because we have too many letters in it, yeah? But right now, it's considered to be solved for P. Why do I consider this to be solved for P?
Because P is by itself on one side.
There you go, exactly. Because the P is completely by itself on one side. But what they're going to do is they're going to give you something like this, and then they're going to tell you, for example, to solve it for L. Now, and here's where the other directions come into play. It will also say, make L the subject of the equation. Okay, so they may approach it differently. Instead of saying solve for L, they may just say make L the subject of the equation. And if it's the subject, that means it's the one you want to solve for. Okay, two ways of saying the same thing. So let's just do that. So we have P equals 2L plus 2W. What letter am I trying to solve for? L. So what I like to do many times is circle the term that has an L in it. And remember that that's my target. I want to get that thing by itself. Is it on one side by itself right now? No. It has that 2W added to it, right? So I need to get rid of that first. Now, if I got rid of the 2 multiplied together, it would be divided, but you don't want to divide first, right? We want to move the 2W. And how is that 2W attached to my L term? Addition. So what will I use to move it? There you go. So we'll just subtract it, but if I subtract it from one side, what? There you go. Now we can't actually do the math, which is nice here. So it just becomes P minus 2W equals 2L. But is my L completely by itself yet?
No.
How is that 2 attached to it? Multiplication. So the opposite of multiply is divide. So I'm simply going to divide both sides by 2. Over here, the 2 will divide away, gives me my L by itself. Isn't that what I wanted? And on this side, I'm left with P minus 2W over 2. Now, make me proud, but think back to yesterday. It's only been a day. Can I now divide these 2's away over here? No, because we have some subtraction, right? Okay? I could only divide it away if all of that stuff was multiplication. Now, what if it was 2W over 2? Could I divide those 2's away?
Yeah.
All day long, right? So be careful. Okay? Yes?
Would it be wrong if you wrote P over 2 minus W?
Absolutely not. But you could do that. That's simplifying it even further, but you don't have to. So most people just wouldn't bother to do the work. But what she's saying is you can say this one divided by 2 and this one divided by 2, which would give you the P over 2 minus 2W over 2, and then those 2's would divide away. And that's another form of the same answer. Anytime you have 2 terms over 1, you could just turn it into 2 fractions if you want to. It usually doesn't do you any real good, though, but you're absolutely, it's one of the formats for the answer. Okay? So they're not difficult if you will just literally follow the steps. And that's one reason why these are such a favorite of algebra teachers. Because you can sometimes guess your way through an equation, right? What number could you multiply by 2 and add a 3 to get you see what I'm saying? But you can't do that with these. You have to know how the steps run to be able to make these work. Okay? So that's one reason we love them so much. All right, now I've got a Miss Brader worksheet. Yay! Okay? I don't know. We'll see. No, I think that she's used this one, so we'll see. All right. So,
Are you impressed?
what now? So, I'm going to put it on OneNote afterward, but I'm not going to, yeah. Yes. Now, so here she's just talking about how the processes go, the steps. She does it in slightly different, she describes it slightly differently than I do, but it's just the steps for solving an equation. So we're just going to go down here. Pardon me? So let's just go down here to some of these and do this. So, all right. So here we go. We'll look at a couple of these because they look worse than these down here, I think. Okay? So let's look at that one. In all of these, we want to make F the subject. Okay? So I'm going to write it down, and then I'll transfer it over to notebook paper so it's not quite as ugly. So we have V equals T. Is that a plus F? T. These things are so small. Times F? Okay, times F. Okay, so just TF then. No symbol needed, right? TF over W. Okay?
There is no. Oh, wait, there's a V.
Okay, so we want to make F the subject. In other words, solve it for F. Is the F by itself right now?
No.
So we've got work to do. But we know it's an equation because you see an equal symbol. Good job. So that means we look first for brackets. Do you have any?
No.
Nope. If you did, you can get rid of those. We look second for what? Fractions. Do you have any?
Yes.
Yes. To clear the fractions, I need to multiply every term by the LCD, or at least common denominator. And the only denominator here is what? W. So I'll multiply this side by W, and I'll multiply this side by W. Because that fraction is all one term, right? Over here, W times V is just WV. Over here, W's will divide away. What's that leave me with?
Yeah.
TF.
What are we trying to find again?
We're trying to get F by itself, so solve for F. There we go. Is the F by itself?
No.
Now, no. How is the T attached to it?
Multiplication.
And the opposite of multiply by T is by T. Over here, they divide away. Gives you WV over T equals F.
Wow.
And you're done. Now, the F doesn't have to be on one side or the other, just as long as it's by itself. Okay?
This is like physics.
Oh, exactly. That's one reason why this is such an important skill, because you don't want to have to solve an equation in physics over and over and over and over when it's not solved, when it doesn't have the right letter, right? So, yeah. It's one of the reasons why it's so common. Okay? Let's look at another one. All right. Look at this next one. We're still trying to get F by itself. So we're going to have the square root of M plus F equals AB. So the square root of M plus F equals AB. Okay? We're trying to solve for F, trying to get F by itself. Now, this time we have a symbol in there that we haven't had in our coursework, but it's a grouping symbol. Literally, the square root of M plus F literally means M plus, don't write this down, in bracket raised to the 1/2 power. So it's still a bracket. It's still a grouping symbol. So anytime you have any of these grouping symbols like that, you need to take care of them like at the very first, just like they were brackets. Okay? In other words, because we have to get that F out from under that thing. Well, it's a square root. What is the opposite of taking the square root? Squaring. So what I'm going to do is I'm going to square this side. But if I square that side, what? Square the other side. Now, when I square this side, these two things are opposites, and opposites always simply eliminate each other, right? So they're gone. So that leaves me M plus F equals, now I have AB, and I don't see any reason to multiply that out to A squared B squared. Because all we're trying to do is get the F by itself. So they don't say anything else about simplifying all this other junk. Let's just leave it. But is my F by itself yet?
No, subtract M.
Yeah, I've got the M attached to it with addition, so I'm going to use subtraction to take it away, which is going to give me F equals, now I can't subtract an M from that bracket, so I just get AB bracket squared minus M. Now that my F is completely by itself, I'm done. Now, if you wanted to simplify that to F equals A squared B squared minus M, you can, but do you see any good in that? Probably not. Right? Just take the time to get it by itself, and once you've got to that far, then just call it done. Okay? How's that look? All right, so think about the opposite operations.
Why did you simplify differently?
Oh, well, I just told you could, but there's no point. But if you wanted to, you can. All right? Let's look at the next one. Okay? We have F plus A over F plus B equals C. Now again, all we're trying to do is get the f by itself. Is it by itself now? No. So we need to first start cleaning this one up. We don't have any brackets, but what do we have? Fractions. So I'm going to multiply by the common denominator, which is f plus b.
Yay.
And if I multiply one side, I have to multiply the other side. Over here, that's easy because they're going to divide each other away, and that gives me f plus an a. On this side, because I'm dealing, one of my f's is going to be over there now, I have to multiply this out this time. Okay? I can't just write c times f plus b. I need to go ahead and multiply it out. So I get cf plus bcb, right? Or any order you want to. I've reversed the order. I don't want to do that to you. Hold on. So it's the same as just c times f plus b, right? So that's cf plus bc. Because you're distributing, because it's f plus b times the c, right? So it's c times both of those things. Okay? Now, again, I'm trying to solve for f. How many f's do I have up here? 2, right? Well, solving them means get them both on one side, yes? Now, you have a couple of choices, all right? But generally, the first thing we do is get our variable terms on one side, right? So let's get the other f term over there. I can move that f over there to the right, or I can move the cf to the left. Doesn't make any difference to me. Which one would you prefer? Move the cf? Doesn't matter to me. It's positive, right? So I'll move it by subtracting it. And if I subtract it from one side, I subtract it from the other. Now be careful. When you get that over there, are f and cf like terms? No. So you cannot actually subtract those. You're just going to write them in order. And generally, it's safer to keep the a separated from the f terms, right? Because you want to get those f terms alone. Now my f terms are all on one side, but is that the only thing I have on that side? I've got that a, right? I need to move it. How do I move plus a? So I'll subtract it from both sides. Gives me f minus cf equals bc minus a. Because they just subtract away on that side. Okay? Now, my f is not by itself yet. And as a matter of fact, my f is distributed into how many terms? 2. Which makes it a common factor. So if you have 2 letters, you can turn it into 1 by factoring.
That's crazy.
Right? It occurs in both of them, and I want it only to occur one time. So I'm just going to factor it out. And again, this is the most favorite problem they're going to give you. Like this. Yes? Of course. Okay?
Would it be negative c?
So, well, hold on a minute. Yeah. F divided by itself, though, is what? 1. Nothing ever divides away. Nothing cancels. That's why I hate that cancel word. Anything divided by itself makes a 1. And then negative CF, if you divide off the F, you're left with negative C. And it still equals BC minus A. Okay. Now I have F times that bracket. What's the opposite of multiply? So I'll just divide by the bracket to get rid of it. Doesn't matter that it's a whole bracket. I can still divide it. That will divide away. And that gives me F equals BC minus A over 1 minus C. Doesn't matter. You don't need the brackets. You don't need anything. And we can't divide C out. And we can't factor it. So it can't simplify anymore, can it? But my F is by itself now. But this thing here, where you have 2 of the letter you're trying to solve for, that, just always get them on one side and factor it out. And I guarantee that if they're going to give you a literal equation, you're going to have to do that. Okay? So make sure that you practice that. Okay? Do you have questions? Sorry. Yeah. Yes?
Would it be wrong if we did negative a plus bc if we wanted to say abc?
Nah, wouldn't be wrong. Not at all. As long as you get your signs right like you did, that's fine. We typically don't want that first term to be negative, but if you want it to be ABC, you betcha. It's fine. Okay? All right. Let's see what she does to us next. Okay? This one is going to look bad, but it's really, really quite easy because there's very little math you can do in these. So A times f squared plus D equals C. This is this D one up that we're doing here. All right? Okay. All right. So AF squared plus D equals C. We're still, again, trying to solve for F or trying to make F the subject. It means the same thing. Is our F by itself right now? No. Is there another term over there with my F term? Yes. So I need to move it first, right? So it's the plus D, so what am I going to do? Yeah, we'll subtract D from both sides. Gives us AF squared equals C minus D. F is still not by itself. I need to get rid of that A, and A is attached to it with what operation? And the opposite of multiply by A is? Divide by A. Thank you so much for that. So that'll divide away. That gives me F squared equals C minus D over A. Now I'm done, yeah? No. New way, because that's the F is not by itself. It's squared. And how do you unsquare something? We'll take the square root of both sides, yeah? Now, the square root of F squared is just F. The square root of C minus D over A is C minus D over A. And technically, if that had been a number over there, if it had numbers in it, you need to put the plus and minus in front.
Oh, yeah.
But since they're all letters, you don't have to. But I would. I would anyway. Because I don't want to ever think about, when I need to and when I don't need to. So if you just get used to doing it always. But you do see why. It's because it's all variables. We don't know if they're positives, negatives, whatever. We don't know if they're rational numbers or irrational numbers. It doesn't matter. Yes?
Can you just divide F from both sides? Will that still work?
I'm not following. Hold on. They really love to give you things like this. Area equals 1/2 base times height. Solve for B. Get the B by itself. So we're going to divide both sides by the stuff that it's multiplied together. And you're going to be dividing by a fraction, which most of you will then have issues with, right? It's a lot easier if you just clear the fractions first. Yes?
Did they write it like that here? This right back, because when I do A equals BH divided by 2.
Oh, yeah. So, yeah. A equals BH divided by 2.
Can you do it either way?
Either way. Means exactly the same thing. Because in the so it means exactly the same thing. So.
Wait, so how would you solve that?
Well, let's look at it. Okay? So first I'm going to clear the fractions by multiplying both sides by what? 2. 2 times A is 2A. Over here, the 2's will divide away, and what does that leave me with? 1BH, which is just BH. Then all we have to do is divide both sides by H to get the B by itself. So clear the fractions. Don't try to work with them. They make your life miserable. Yeah? And clearing the fractions is really quite easy. All right? Okay. So let's look at a couple of those that she has and see if there's any really oddballs that we need to look at together. And then I'm going to set you loose with this. I'm going to put this on your OneNote. And so you're welcome to print it off, do whatever. I don't ever put them on there until we get together to look at them because I want to see if I want to use them because I don't want to put up those things with a lot of mistakes. So.